Okay, so today what we are going to be doing is developing our understanding of the number of solutions to a system of linear equations. The first thing I want to do is just go back and talk about a system. When we have a system, we're going to have a brace, and then we're going to have two equations written down. This is a system of equations in two variables. The reason is, again, because I have x and y. So earlier in the week, we practiced graphing a system in two variables because this is a linear equation that we know how to graph. I'm going to show you how we can use our knowledge from solving equations in one variable to have a better understanding about our systems. So if we look at these two equations, they're both set equal to y. So I'm going to write the first one down here, x plus 2 equals. And again, it's equal to y. My second equation is telling me that y is equal to x minus 1, or y is the same thing as x minus 1. So instead of putting y here, I can substitute y for x minus 1. When I do that, I have now taken my system of equations in two variables, and I've turned it into solving an equation in one variable, because I'm only left with x now instead of x and y. When I take a look at this one here, if you look, one of the things you will notice here is that my coefficients are the same, and my constants are different. So if we look at that pattern should be telling us that this is a no solution. Now, the question is whether or not that holds true when I graph. What we're going to do is we're going to go back here to page 275 in our textbook, and we are going to take a look at graphing this. So it says here, you've seen that a solution to a system of equations is represented on its graph as a point of intersection. The ordered pair for this point makes both equations true. Graph these equations. So for this one, my y-intercept is 2, 1, 2, and my slope is 1. Up 1 over, up 1 over. I'm going to just come backwards a little bit just to really extend this line so we can fully see. Line through. And some arrows. I'm going to go ahead and graph now my second one. My y-intercept is -1. And my slope is 1 again. Up and over, up and over, up and over. Going to go ahead and extend this. Now that I'm done graphing, what I should notice here is that this is a no solution. Again, this is a no solution due to the fact that there's no intersection of my lines. These lines are parallel. So therefore, they're never going to intersect. Now, how do we know we're going to get parallel lines? One thing I want you to take a look at while you are working on this is my y-intercept and my y-intercept. Those y-intercepts are your starting points. So B equals my y-intercept. That is my start, also known as initial value. Okay, so This is starting at 2, and this is starting at -1. Then we're going to look at our slope. Our slope here is the coefficient to x. So my slope is here, and my slope is here. We call this our slope. We also call this my rate. So when we're looking at the slope here, the slope is the same for both of these problems. That means that it's growing at the same rate. However, this is starting at 2, and this is starting at -1. So if we start at different spots, but then grow at the same amount, our growth for the -1 will never catch up to the growth of this line. That is why it is no solution, and we have parallel lines. Okay, going on to this next one here. Looking at Charlotte and Paloma. Both hike the same trail at the same rate. Charlotte starts to hike first. The graph shows each girl's distance along the trail for their first 40 minutes of Paloma's hike. Does Paloma catch up to Charlotte? How do you know? So what we need to do here is we need to figure out the rate of each person. So Paloma, this is up and over, up and over, up and over. Based on the scale here, this line should be 250, and then we're doubling 250 every time. So this is 750. So the rate here is up 250 over, this is growing by 5s. So that is delta y over delta x, and that's 250 over 5, which is going to leave us with 50. So Paloma's rate is 50. We're going to go ahead and look at Charlotte now. Charlotte goes up and over, up and over, up and over. So if we look at the growth there, that is going to be the same. Charlotte is going up by 250 and over by 5. So Charlotte's rate is also 50. Now, because they started at different distances, but they're going the same rate, Paloma is never going to catch up to Charlotte because these are parallel lines. Looking at the system of equations, how can you tell by looking at the equations that the system has no solution? So if you've noticed in the last two problems, any system where the slope is the same, so slope is the same. If you want to discuss solving equations in one variable, this would be the coefficient, okay? So slope is the same, but our constant or our initial value is different. So initial value, y-intercept, is different. So the initial value or y-intercept is different. If we want to look at this in terms of, again, solving an equation in one variable, then we would be saying things like the coefficients are the same, constants are different, therefore it's a no solution. On a graph, what we're going to say when we have the two variables is that the slope is the same, y-intercepts are different. Okay, moving right along. I'm going to go ahead and take a look here. So the graph of the equation y minus 1 is equal to 2x is shown. Graph the equation y equals 2x plus 1 in the same coordinate plane to represent a system. At which points do the two lines intersect? Okay, so graph this equation. Y-intercept is 1. So I'm going to go up to 1. I'm going to plot my point. My slope is 2. So I'm going to go up 2 over 1. I'm going to go down 2 to the left 1. And which points are the same? You can see here, all points are the same. So how many ordered pairs are solutions of the system? This would be infinitely many solutions. If you look at the first equation, which was y minus 1 equals 2x, and we go ahead and we write this in slope-intercept form, we're going to start by moving this to the other side so my y can be isolated. Therefore, this is a plus 1 plus 1. I have y equals 2x plus 1. If you look at the second equation that I boxed here, it's y equals 2x plus 1. Those are the same exact equations. Therefore, they're the same line and have infinitely many solutions. Lastly, coming down here, we are going to look at problem 5. What values of m and b will result in a system with no solution? So no solution patterns have the same coefficient, different constant. So what is going to give me a no solution? Same coefficient. When I look at my top one, my coefficient means that m is going to have to equal 4. And b, it has to be a different constant. So it's anything, any number except 5. So if I put my slope in as 4 and I give any number other than 5, I will have the same coefficient, different constant, and therefore no solution. Okay, lastly, look at problems 1 through 3. In each system of equation, both lines have the same slope. Can two lines with the same slope ever intersect at exactly 1 point? So again, this is following this pattern here. Same coefficient, different constant. Coefficient is my slope. My constant is my y-intercept. So if I have the same slope but different constant, then I am not going to have a solution no matter what. Okay, so we are using our knowledge of graphing plus our knowledge of solving equations in one variable, now to solving equations in 2 variables, and having a better understanding about the number of solutions in a system of linear equations.